try it again. All right, so study set 10. A, B, and D are esters. C is not, because again, there's 2 carbons there. We're going to name these. I know the question didn't tell you to. The trick for naming, though, is the side that does not have the carbon double bonded oxygen, the other side of the oxygen, circle that piece. And that piece you circled is always has to be named in one word as a side group. So the YL ending. And that's the first thing you do. So you write methyl. And then our other side, we would just number starting with the double bonded oxygen. So 1, 2, 3. And this is another methyl. You do not combine these methyls. This methyl that's in orange, that gets its own position. So then 2-methyl propanoate. That would be the IUPAC way to say it. This is also an isobutanoate. So you could also say methyl isobutanoate. Esters are probably the trickiest ones, just because it's a very different way of naming with this extra piece. When we see this with the nitrogens, it's not as hard because the nitrogen stands out more than the oxygen, I think. All right, on our next one, this is the side that I'm going to circle in the orange, the side that doesn't have the double bonded O. So that is an ethyl. That's going to be the first piece we name. And then the double bonded oxygen gets the number 1. So 1, 2, 3. And so propanoate. All right. On D, we're not going to name D. I could name C, but I'm going to go ahead and name C. On C, this has to be named as, in the blue, that would be named as a methoxy. Just because some of you may end up doing something like this, there's the isomer question on the worksheet, and if you end up, this is legit, it's a ketone with an ether, so this is an ether, and then that's a ketone, so it'd be methoxy at carbon number 2, so we'd say 2-methoxy, and then cyclohexanone. D is an ester. So it's an ester. I don't remember how to name the cycloesters, and so you're not going to be responsible for that. I'm sure Google has all the answers. All right, let's go ahead and keep naming. So circle the side that does not have the double bond. Like on that one, it would be that, the methyl. This would be here. On this one, it's over here on this side. So it's not that it's always on the left. It's just however you're looking at it. And so that's the piece. And that's really the key to naming these. And that piece gets named first. So this would be methyl. On this one, it's propyl. It's at the very beginning of the name. On C, it's an ethyl, and D, it's an ethyl. And it's going to be something you can name. So an isopropyl, an isobutyl, and then our other side, we start numbering 1, 2, 3, 4. So butane, oops, and then O8. And on this one's 1, 2, 3, so propanoate. So the weirdest part is you can end up, like on this one, this is only 1 carbon, and you can name it as methanoate, which is fine. Nobody uses that term except chemistry students, but that's fine. Instead of methanoate, you can say formate. So 1 carbon is often named as formate or formic acid. What did formate stand for, or formic acid? Oops. Anybody? Comes from the ants, right? When we squished Auntie Annie. All right, on this side, so the double bonded oxygen carbon gets number 1, so just like we did with acids. So this would be butanoate, but we have to say those methyls in there before butanoate and after the ethyl. So again, the ethyl gets to be first, and then we have to say there's a 2,3-dimethyl. So the names come out really long and seem really bizarre, And possibly if you do it in 2 different colors, that will also help you. Yeah, and same like up here, if you have this methyl, you do not combine it with that methyl. You don't make it a dimethyl. This one that's colored, circled in the orange, the other side of the oxygen is special, and it's just always named first and separate. Any questions? All right, so now we're going to draw and do reactions. So methanoic acid would just be a 1-carbon acid. And so they typically show the hydrogen. You can show it just next to the carbon or with a line. And then the propanol, when you do these, you just want to draw them so they're facing each other. So 1, 2, 3, and you can lasso your water molecule. It doesn't really matter how you lasso it. You're just going to take the OH off of one of them and the H off of the other one, and then you hook them together. So you have your double bonded oxygen with the carbon, and then we have our oxygen here. Doesn't matter what color you make your oxygen, and then that's the propyl. So the name, we're going to name it. Our orange side is propyl, and our other side is 1 carbon, so methanoate or formate. So hopefully, like once we get through the homework, usually this is where it starts clicking for most students. Propanoic acid would be our acid. So 2, 3, that would be, so this would be our first carbon. And then ethanol would just be 2 carbons, so 1, 2. And when we put it together, our reaction, you can circle your water. And again, it doesn't matter how, but it can help to circle the water for many students. And our oxygen. So this is going to be ethyl. The piece that comes from the alcohol is always going to be that extra piece that gets named first. So ethyl propanoate. So some students actually can do the names first, and then they do the drawing because they see what's coming, where it's coming from. All right, propanoic. And there's a methyl coming off there, plus, I guess I didn't show my plus. And then 2-butanol. So that would be the sec-butanol. So 1, 2, 3, 4. You can draw it like that. You can draw it as a zigzag. It's kind of a personal choice. Doesn't really matter. It's the same thing. But you want the OHs pointing towards each other so you can circle them. Question that Isabella had asked me during the office hours: do you have to say plus water? I don't care. You can show the plus water. What I find is about half of you like to write plus water, and about half of you don't really care about that part. Is your teacher. So there's our 2-methylpropanoate, and then our other side is going to be the sec-butyl, however you draw your sec-butyl. So our name is going to be sec-butyl. I know it didn't ask you to name, but I asked you on the worksheet, and it's always good practice. And then this side, you can do isobutanoate, or we can do the 2-methylpropanoate. This part also could have been named isobutanoate. Oh dear. Sorry, my handwriting got all crunched there. All right, so bentanoic acid. So again, there's carbon 1, 3, 5, and we're going to add it to isobutyl alcohol. Consider how far you guys have come. So 2 months ago was the first time I would have introduced to you all the butyls, so sec-butyl, and an isobutyl, and right, that there's going to be the kink, right? We have that elbow, and now you can do them. You're like, oh yeah, okay. You're going to have such an advantage next term in 106 for those of you who are taking 106. And I will have an advantage because I'll see familiar faces again. So that's a huge help for me. Sorry, I'm anticipating the question that's going to happen the first week from those of you who take Chem 106, and that's why I'm smiling. So this is isobutyl. We named the orange. I'm just putting it in orange today to help you differentiate that side. The colors are helpful. So the isobutyl is the side other than the oxygen, over on the other side of the oxygen. It doesn't matter if you drew it, flip the mirror image of this or not. And then this is pentanoate. So questions. And again, I know it didn't ask for all these names, but it really helps to just practice them when we can. There's no questions. Go to the second page. And I still have her beautiful picture in there of the tree. There's my no mud, no lotus. And right now there's no mud out there. That sun was so nice and warm today. All right, so there's our piece. We'll use pink now. Ethyl, and this side with 2 carbons. You can name it as ethyl ethanoate, which is just like, feels like it should be the name of a character in a kid's book. So ethyl ethanoate, or you can name it acetate for vinegar. There's 2 carbons. So ethanoate, it could be ethyl acetate. On this one, sorry, I should have put the ethanoate and the acetate in different color. So that's our 1, 2 here. On this one, this is 1, 2, 3. This is the piece. So it's on the left or the right. It's the side that does not have the carbon double bonded oxygen. So that is just methyl and then propanoate. Right, on this one, ethyl again gets circled first. And this is benzoate. So you can never have the double bonded oxygen directly on the benzene ring. There's always that 1 oxygen in the middle. I'm sorry, that 1 carbon. And that's because there's just not enough room as far as bonds. You know what's missing from this study set, I just realized, is all the questions about boiling point and solubility. We get a lot of reactions and stuff. And on this one, so that's our piece. That's a phenyl. So YL ending. And again, I don't know if that's how you say it. I just say it that way to try to distinguish it for students. And on this side, 1, 2, 3, 4. So a 3-methyl butanoate. One thing I did not mention is there's actually a space here. It's kind of funky. In all the rest of the stuff we've done, everything gets crammed into 1 word with dashes and commas. So technically this methyl runs right into the butanoate. It's all 1 word. This is the one time when there's actually space. There's no dash. There's nothing. I think with cis trans, I can't remember. Sometimes people put dashes and sometimes they don't. But with esters, there is actually truly a space. My personal opinion, I don't really care if you guys put a dash, if you put a space. I usually put a space here because I think that's how our brains, or how you've been taught by me, and so my brain sees them as parts. All right, so we're gonna do the reactions, and the trick is cutting it. You don't have to be perfect in cutting it, but I think it's easiest if you cut next to, between the carbon double bond and the oxygen. So that's one way you can do it. Another way you can think about it, if you're circling, is this part that you circled in pink, this ethyl, that's going to become the alcohol. So you can pull that part off and just make that into the alcohol. And then the other side is going to be your acid. And they each get an OH. So we get acetic acid or ethanoic acid, and ethanol are for A. So if you like that, you can do it that way, where if you circled the piece, so that piece that's in pink would be CH3OH, so that would be our methanol, and our other piece is going to be our acid, so propanoic acid, so 3 carbons. So the propanoate at the end becomes propanoic acid. And the alcohol was methanol. And again, I didn't ask you to write the names, but I have found that many students' names actually help them to see the molecule better, especially because when we're writing stuff and trying to copy from what I'm writing, and especially in this environment, sometimes we get off by a carbon. I do that too, and so that helps to make sure when you're going through it. You can also do where you cut it, if that makes more sense to you. And it's up to you if you like the colors, which I'm seeing a lot of you do, that this side gets this, one of the sides gets the oxygen. Doesn't matter which side, because they will both get an oxygen. And then you're going to add the OH to whatever side's missing the oxygen and the H. So we get the 2 pieces. You're going to end up with an O and a HO. They're going to be facing each other. And so this is benzoic acid. So we had benzoate, so that makes sense. And ethanol should be our alcohol, so ethanol. So again, find the way that for your brain works. All of us look at these things slightly different. So if you like cutting it in 2 like that, you can draw this as zigzags. I plagiarized the questions, that's why. And then we'd have an OH. So this would be 3-methyl butanoic acid. I don't know what the common name for this one would be. It is, because there's 5 carbons. And then our other side is going to be phenol. So it's just straight phenol. So questions with that? It just takes practice, because they're actually they're really not that bad. All right, and so more of these. So there is a difference here whether we're using the NaOH or not. So on the worksheet, there's one with NaOH. So with the water, yeah, we're cutting them. So in this one, technically, it was trying to say, hey, we're building this. This was the product, but it's the same idea. So we're going to cut on A, we're just cutting it. So our alcohol, our acid, and then the alcohol is just the methanol. And yeah, it's just straight water. This is just saying we're keeping it in an acid environment, so this H will be on here. On the second one, we get the same, we cut it the same way. You're still going to get the methanol. The difference is that hydrogen comes off and we'll have a sodium on there. So the NaOH is going to pull the hydrogen off, and we would have a sodium on there, and then still plus the methanol. So just to review the name, this would be, we would number 1, 2, 3, 4. We say the sodium first, so the name would be sodium, and then 3-methyl butanoate. That may have been the one that was on the worksheet from Monday. The sodium goes at the very beginning. Like, I think almost every single one of you wanted to say 3-methyl sodium butanoate, but the sodium goes at the very beginning. All right, on C, use a different color. This is our piece here. This is going to be 6 carbons. So that ch105 is just saying there's 5 carbons in a row and then another carbon. So this is just hexanol. We would want to say that the OH is at number 1, or we put a little N for normal. And then my other side is 1, 2, 3 carbons. So you can do it as zigzags if you prefer. We get propanoic acid. All right, and then our last one is, I'll just do it down here, CH3, CH25. You can go to zigzags. This is just saying we have 7 total. So we'd have 1 plus 5, and then that would be number 7. And this is going to be our acid, but the NaOH is going to pull the oxygen off, and we'll put a sodium on there. So this would be sodium heptanoate, would be the name for that. And then the other side is, we'll go back to the orange, is ethanol. All right, questions? All right, I'm going to stop and switch to our notes.